Good morning, students. Today we will discuss the topic friction from chapter 17, friction only. Okay, so today we are going to discuss title of the chapter, that is friction, or we can say that frictional force or force of friction. First of all, it is a kind of contact force which acts between the two objects that are in direct physical contact with each other, that are touching each other. So, any two objects or surfaces which are in direct physical contact with each other or touching each other, then there is a force acting between the two objects or two surfaces, that is called contact force. And frictional force or force of friction or friction is a kind of contact force only which acts between the two objects or two surfaces that are in direct physical contact with each other or touching each other. Now, what is this friction specifically? See, when two objects are in direct contact with each other or touching each other, and one object is moved over another object, then there is an opposing force acting between the two objects which reduces the motion of moving object. Okay, look here. There are two objects which are in direct contact with each other or touching each other, and one object is moving over another object. Then there is an opposing force acting between the two objects, between two surfaces, which reduces the motion of the moving object. This kind of contact force is called frictional force or force of friction or friction. Now, examples of frictional force. See, you must have observed that when a moving ball which is rolling over the ground, after some time it stops. No one collects the ball, no one stops the ball. Even then, after rolling or moving over the ground for some time, it eventually comes to stop. Why? Because of the frictional force or force of friction or friction exerted by ground or field on the ball. See, this is a ground over which a ball is rolling. Now this ball is in direct contact with the ground. It is touching the ground directly. So there is an opposing force acting between the two surfaces known as frictional force or friction. Okay, now this ball is moving in this direction, or I can say in forward direction. Okay, now frictional force exerted by ground or field on this ball, which is an opposing force, it exerts on the ball in opposite direction to its direction of motion. If it is moving in forward direction, then the opposing force or frictional force exerted by ground or field on the ball is in opposite direction to the direction of its motion, that is in backward direction. Okay? This opposite frictional force reduces the speed or motion of the ball. And when this frictional force becomes higher than the applied force, then it eventually stops. Before that, applied force on the ball is more than the frictional force, is more than the opposite force. So, ball was moving in forward direction. And as the frictional force increases, its speed, its motion reduces, and when frictional force ultimately becomes more than the applied force, then its motion is stopped. It eventually comes to rest. Okay, its speed becomes zero. Okay, now there is one more example. We have a large heavy carton placed on the floor. Now we intend to move it in a particular direction, but it is not moving further. Why? Because this carton is in direct contact with the floor. It is touching the floor. So these two objects or surfaces are in direct contact with each other, are touching each other. So there is an opposing force called frictional force exerted by the floor on the carton in opposite direction. And this frictional force does not allow this carton to come into motion, because this frictional force is acting in the opposite direction to its direction of motion, and this frictional force is equal to the applied force. So if applied force on the object is in this direction, okay, for example, it is of 10 Newton, then the frictional force, which is an opposing force exerted by ground on the carton, is in opposite direction, that is equal to this applied force. So that is also 10 Newton. Okay, but it is in opposite direction. So I will write here minus. So there are two forces. One is applied force in forward direction of plus 10 Newton. Another is frictional force, opposing force in opposite direction, minus 10 Newton, acting on the same object. So this object carton experiences two equal but opposite forces. So both these forces cancel, nullify each other. So the net resultant force on the object or carton is 0 Newton. It means it experiences zero net or resultant force, which brings no change in the object. So this object will not move anywhere, will not undergo any change in terms of state, in terms of speed, in terms of direction. So what we have concluded or learned? We have concluded or learned that when two objects are in direct contact with each other or touching each other, and one is moving over another or intended to move over another, then there is an opposing force or frictional force acting between the two surfaces or objects, which reduces the motion of the object or speed of the object, okay, known as frictional force or force of friction or friction. This friction or frictional force always acts in the opposite direction to the direction of the motion of the object. Okay, next thing which is also important, this frictional force may be less than the applied force or equal to applied force. If it is less than applied force, then what happen? Applied force on the object makes the object to move in a particular direction, and frictional force acting on that object is acting in the opposite direction, and I am saying that frictional force acting on that object is less than the applied force. It means applied force is more, so that object moves in the direction of applied force, like here in the forward direction, and frictional force is acting on the backward direction. Okay, so object moves in the direction of applied force because applied force is more. Okay, and frictional force is acting in the backward direction. But this lesser frictional force reduces the motion and speed of the object. Okay, and when this frictional force becomes more than the applied force, then it stops the motion of the object. It decreases the speed of the object to 0. Okay, and in another case, if applied force is equal to the frictional force, it means two equal but opposite forces are acting on the same object. So net resultant force on the object is 0 because two equal and opposite forces are acting on the same object, so they cancel, nullify each other. So net resultant force on the object is 0, which brings no change in the object. Okay, in terms of state, direction or speed. Understood? And if you want to move this object, then you have to apply applied force more than the frictional force. Okay? Now, as I told you in chapter Force and Pressure, that forces can also be categorized into two types: balanced forces and unbalanced forces. Now, what are balanced forces? This is the case of balanced forces. Here, two equal but opposite forces are acting on the same object. Okay? So, when two equal and opposite forces acting on the same object, then they cancel, nullify, neutralize or balance each other. In that case, zero net or resultant force acting on the object, which brings no change in the object. If object is in motion, then it remains in motion. If object is at rest, then it remains is at rest. If object has a speed, it will move with that speed. If object is moving in a particular direction, then it will move in that direction only. So there will be no change in terms of state, speed or direction if balanced forces are acting on the object, because no net or resultant force is acting on the object, because 0 0 means no net or resultant force is acting on the object. This kind of forces are called balanced forces. So balanced forces are the equal but opposite forces acting on the same object, which cancel, nullify, neutralize or balance each other. So a zero net or resultant force is acting on the object which brings no change in the object. It means in case of balanced forces there is no change in the object. Okay? And if we talk about unbalanced forces are the forces which do not get cancelled or balanced or neutralized by any other equal or opposite force. So a net or resultant force is acting on the object which brings change in the object. For example, here on this ball, if there is an applied force of 10 Newton in forward direction and ground exerts a frictional force, an opposing force, obviously in opposite direction, in backward direction, that will be in minus 5 Newton. So there are two forces, 10 Newton minus 5 Newton. These two forces are unequal but opposite in direction. Okay, acting on the same object. So these two unequal but opposite in direction do not cancel or balance each other. Okay, now just find out the net or resultant force acting on the object on this ball. There is an applied force of 10 Newton in forward direction and an opposing or frictional force in opposite direction, backward direction, that is minus 5 Newton. So this experiences plus 10 Newton minus 5 Newton. Two unequal opposite forces. So net or resultant force is 5 Newton. So here two unequal opposite forces are acting on the ball or object which do not cancel or balance or neutralize each other. So a net resultant force of 5 Newton is acting on the object which brings change in the object. That is why that object is moving further. So there is a net resultant force of 5 Newton acting on the object. Okay? So this kind of force is called unbalanced force. So when there are unequal opposite forces acting on the same object, then they do not cancel, balance or nullify each other. So there is a net resultant force acting on the object which brings change in the object. That is why this object is moving further. Okay, and it moves in the direction of greater force. Applied force is greater, so it moves in the direction of applied force. Now next topic is cause of friction. What is the cause of friction? Why a surface exerts a frictional force and opposing force on the object moving over it, which reduces the motion or speed of that moving object. Okay, actually when you look at the surfaces of two objects, they seem very smooth, but if we observe their surfaces with the help of microscope, then we will find that their surfaces are not so smooth. Their surfaces have many microscopic irregularities. So, surface of this carton and surface of floor, ground, both have surface of carton, this, surface of floor, this. Both have many microscopic irregularities. So what they appear is not the correct picture. They appear that they are very smooth, having no irregularities, but actually they are not so smooth. They have many irregularities in their surfaces. So when a carton or box is moved over floor, then irregularities in their surfaces get interlocked with each other, which gives rise to frictional force and opposing force, which reduces the motion of moving object, because these interlocks reduce, resist or oppose the motion or speed of the moving object, known as frictional force or force of friction. Rough surfaces have many irregularities, so they have more interlocks as they have many irregularities. And these large number of interlocks due to large number of irregularities on rough surfaces, a large frictional force is exerted on the moving object, which reduces or opposes the motion of the moving object greatly. On the other hand, smooth surfaces have less irregularities, so they have less interlocks, which give rise to less frictional force, and due to less frictional force, the motion or speed of the moving object is reduced but up to lesser extent. Okay, now there is an activity. Take a brick. Tie this brick with a spring balance. Spring balance is a device or instrument by which we can measure force. Okay, now you have to take a brick, tie its one end with the spring balance. Okay, and hold another end of spring balance with the help of your hand. Now apply force with the help of spring balance on the brick. Then what happened? This brick moves over the floor. Record the reading in the spring balance. What reading? Reading of force. Okay? Then wrap this brick with polythene bag or plastic cover. Now again repeat the same activity. Hold the free end of this spring balance and just apply force with the help of spring balance on the brick. Now again record the reading of force. In first case, the reading of the force is more as compared to reading of second case. Why? Because in first case, brick's surface, which is very rough, having large number of irregularities, get interlocked with the irregularities of floor. Okay, what number of irregularities? So they get interlocked more, and due to large number of interlocks, a large frictional force is exerted on the brick by the floor. Okay, and in order to overcome this large frictional force, we have to apply large applied force by spring balance. So this shows more reading. Okay, understood? Now, when we wrap this brick with polythene bag or plastic cover, then its surface becomes smooth. Now it has comparatively less number of irregularities which interlock with the irregularities of floor. But this time irregularities are less in number, so they get interlocked up to less extent, which gives rise to less frictional force. And to overcome less frictional force, we need to apply less applied force by the spring balance. So spring balance shows less reading of applied force in second case. So this shows that rough surfaces have more irregularities which interlock more, give rise to large frictional force. On the other hand, smooth surfaces have less irregularities which interlock less, give rise to lesser frictional force. Okay, this is all for today. Thank you. Have a nice day.